Today we are going to discuss the past paper questions from NMR spectroscopy, which includes both carbon-13 and proton NMR. Okay, let's start with this. A compound F is a carboxylic acid. F contains 31.4% oxygen by mass, and its mass spectrum has the molecular ion peak at 102. Use all the ensure that the molecular formula of this F is C5H10O2. You remember we have to use the empirical formula and keep peak whatever. So we are not gonna do this here. We come to this question, right? So he's asking us first to draw, there are four possible structural isomers which are carboxylic acid. The first isomer has been drawn here. Okay, draw the skeletal formula for three other isomers. Okay, so you have to draw the skeletal formula for three other isomers, right? So here are the four possible structural isomers for this C5H10O2. Okay, the first one I have shown here, 1, 2, 3, 4, and this is a branched. Okay, so the other isomers you have to show. Let's put all 5 carbon in one chain. Okay, so 1, 2, 3, 4, and then 5. Okay, we have to draw the skeletal formula, so let's draw it in the skeletal form. So all 4, 1, 2, 3, 4, and then 5. This is double bond OH. Right? 1, 2, 3, 4, 5. What else, Aries? 1, 2, 3. 1, 2, 3. 3, and then I can put here. Okay. Yes. And then 1, 2, 3, 4. Okay. This is not same thing. Okay, they're not the same thing. This is the one is 2-methyl butane. And 3-methyl butane. 3-methyl butane. Okay, you see the difference? नेक्स्ट कौन सा होगा? This one. Next क्या होगा Aris? All putting like this. So here it is 1, 2, 3 carbon. So it is 2,2 dimethyl propanoic acid. That's also 5 carbon, na? And this was pentanoic acid. Got it? Okay, next, name the systematic name of isomer 1. We have already written, what is the name of isomer 1, bacho? Sorry? 2-methyl butanoic acid. F is one of the 4 structural marks, so carbon-13 spectrum is shown. Use the spectrum to identify the isomer F and draw its structure in the box below. So he's saying that this is the isomer F. I told you, okay, first use the structure to assign the peaks. And then look at this. For example, how many peaks in this spectrum? I'll just to keep in mind. How many peaks? 3. Keep in mind, this is carbon 13's NMR, okay? 3 peaks. Now I have to see which compound is going to give 3 peaks, starting with isomer 1. Can you see the isomer 1? How many peaks isomer 1 is going to give? Isomer 1. Isomer 1. Delma, how many peaks? 4. Aris, this carbon has unique 1 peak. This has 2, this has 3, this has 4, and this has 5. So 5 peaks for this. So this is not my answer. Why? Because I'm looking for how many peaks? Yes, go ahead. No, 3 is CH2, 4 is CH3. They could not have 1 peak because they have different number of hydrogens attached with it, different environment. Everything is different, okay? Next. Okay, next. Okay, what about number 2? No, what about number 2? Obviously, it's going to have more peaks. 1, 2, 3, 4, 5. All have different peaks. What about number 3? 1, 2, 3, and these 2 have the same peak. So 4 peaks. Still not the answer? Why? Yeah, we're looking for 3 peaks because the NMR spectrum, which we are referring, it has 3 peaks. What about this now? The only leftover 3 peaks. This one, and all these 3. They are the CH3s now. So they are going to have 1 peak. Okay? So now what about this? 1, 2. Okay? Now what about this then? 3 peaks now? Tell me the chemical shift values. Please use the data booklet. Carboxyl. What do you think about the carboxyl? Yes, 160 to 185. What about next to C double bond O? This one, number 2. 25 to 50. Are you sure? Next to C double bond O. Okay, and what about the alkyl one? 0 to 50? 0 to 50. So there are 3 peaks. 0 to 50, 25 to 50, and 160 to 185. 160 to 185 we have found here. That is for C double bond OH. This is for 3 CH3s, 0 to 50. And this is for C, which is next to C double bond O. Okay? Got it? Okay, now we know the structure. So what is the structure now? This one, C double bond OH. And then there's a 1 carbon and 3 carbon attached here. So I hope you got my point and you got my thought process as well. You have to do the, I'm telling you, you just follow the procedure. Okay? Next.
Could you explain the chemical shift part again?
Shift. Chemical shift, we have to look at the data booklet. I have to go to the data booklet again, okay? For example, look the data booklet. Let me show you the data booklet. Look at the data booklet. Okay, here is the carbon 13 wala spectrum, Lilma. So let me draw the structure here and then ask you the peaks, okay? For your understanding, we are going to do this. Look at this. The structure which we are looking for was this. C double bond OH and then C, and there are 3 CH3s. This is peak for carbon, na? So here is the first carbon. This carbon, which is C double bond O and next to OH, is known as carboxyl. And where is carboxyl? Can you see the carboxyl? Okay, so you agreed to 160 to 185 for this carbon in the carbon-13 NMR spectrum peak. What about this C that is next to C double bond O, the neighbor of C double bond O? Just go top. The neighbors are on the top. Look, look at this here. You see my arrow? Next to carboxyl, the carbon which is next to carboxyl, the neighbor of carboxyl, where it gives. Okay, so for this 25 to 50. And what about this? These three, which are alkane and next to alkane. Next to alkyl, look, the one on the top, the first one. What about this? 0 to 50. Now you got it? So you have to see the carbons which are not part of functional group, and next to the functional group, they are on the top here, these ones. And then underneath here, these are the ones which are the part of the functional group. So if they ask you that COOH wala carbon and CH3, iske liye they ask you next to carboxyl. What is this? Next to carboxyl. And for this, carboxyl. Okay. Got it? For this, it's a carboxyl. And for this, next to carboxyl. Do you get it? Okay, next. Now, should I go back to the? Okay. Here is the question again. So next is here it is. G is another four structural isomers of B. Proton NMR spectrum of G is shown. Okay, now let's come back to this again. How many peaks in the proton NMR? 1, 2, 3, 5. Where is the fifth one? The peak at 0 is because of the TMS. This is a reference compound peak. Just forget it. Okay? Just look at the peaks. How many peaks? 1, 2, 3, 4. Now I'm going back to that and going to assign the peaks of hydrogen. And I'll be targeting the carboxylic acid that has how many peaks? 4. Okay? So let's see. Okay, here it is. How many peaks for this? These are the peaks of hydrogen arrays. Here it is CH3, CH2, here it is CH3, and here it is CH. So how many peaks for this? 1 for this hydrogen, 2, 3, 4, 5. All these hydrogens are different. No, how could it be the same? This CH3 is next to CH and CO. No, they cannot be the same. This CH3 is next to CH and then CO. Okay. Do you get it? You just don't look at the neighbors. And even if you look at the neighbors now, इस CH3 के neighbor में कौन है? और इस CH3 के neighbor में कौन है? CH, not CH2. How they could be the same environment? They are absolutely different. So how many peaks? 1, 2, 3, 4, 5. 5 peaks. So not the answer we are looking for. 4 peaks. What about this? What about this? 1, then 2, 3, 4, 5 peaks. Okay? So this pentanoic acid, all the hydrogens, they are the same. Every carbon hydrogen has this different peak. Okay? Now come to this one. Isomer 3. Please pay attention. This is COOH. This has one peak. Then this CH2 has one peak, 2. This has 3. And these two CH3s has one peak. So how many peaks? 1, 2, 3, 4. Probably this one.
So could you explain the isomer 2 again? How is
Every carbon is different from the other.
4, 3?
Look, this is CH3, CH2, 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 COOH. Now, everyone is different from other. How? COOH is different? Now, answer me. Different? CH3 is different? Now come to the CH2s. They are confusing for you. इस CH2 के neighbor में CH3 है, can't be the one. और कोई ऐसा नहीं है. इसके neighbor में COOH है, कोई और ऐसा नहीं है. This CH2 is a unique from all other 3 because their neighbor, this CH2's neighbor is CH2 on the both sides. So they all are different. Okay? Don't look just CH2s. Just look at their neighbors as well. Okay, now इसकी 4 peaks होंगी. By the way, इसकी कितनी होंगी? 1. एंड यहाँ तो कोई हाइड्रोजन है ही नहीं ना इस कार्बन के पास. सो इन 3 की 102 पीक्स. So now I know not this, not this, not this. So we are left with this answer, right? But we have to confirm it. Okay, let's go to the data booklet and confirm it. Okay. Here I'm going to draw it again. COOH and then CH2 and then C. C. Probably CH3, CH3. Here is the structure. Now, how many peaks? Let's look at the peak. 1, 2, 3, and 4. 4 peaks. Now look at the chemical shift values. Use the data booklet, bacho. This is 9 to 13 and will be a singlet. You know, this also contains peak splitting, and I can see the splitted peak, so I have to assign the splitting. What about this? 2.2 to 3 or 3.2 to 4? Next to C double bond O. Next to C double bond O. 3.2 to 4. And what will be the splitting? Doublet. Why doublet? Neighbor mein there is a 1 hydrogen, okay? 2.2. Next to CO. Next to CO is 2.2 to 3. I think you are again must be looking at carbon 13 spectrum.
No.
You're looking at the hydrogen spectrum?
Yes.
Okay, then look at the hydrogen attached with the carbon and next to C double bond or next to carbonyl. Got it now? Okay, next. What about the next? 0.2, 1.7. What about this? क्या है ये? No, I mean splitting. Should be what? Multiplied. 3, 3, 2. 8 hydrogens around it. Okay. The last one. What about that? 0.9 say. That is what? That is doublet. Okay. So can you now spot these peaks here? Multiplied. Here. Then singlet here. Then दो डबलेट्स हैं. ये डबलेट बड़ी वाली इसकी वजह से होगी और छोटी वाली इसकी वजह से होगी. And now you have to fill this data. So 0.92 CH3 की वजह से है. Number of protons 3 हैं और डबलेट है. Then 1.6 पे जो है वो 1 है और मल्टीप्लेट है. Then CH2 next to CO 2.4 पे है, and that is number of protons 2 and that is doublet. And finally 11.5 पे जो है that is COOH की वजह से 1 और singlet. Okay, you just fill the data in the table which we just fought. Okay, next. So structure. So we have to draw the structure of G here. So it is C double bond O OH, and then CH2, and then CH, and then CH3. Here it is CH3. Clear? Okay, next. Name or give the formula of suitable solvent obtaining proton NMR spectrum. What is the formula used? CdCl3. Okay? CdCl3. Okay? CdCl3. Right? Next. Okay, next is okay, so the next question is ethane dioic acid can be converted. State a suitable reagent for this reaction. What is the reagent for this reaction? G COOH. Turns into COCl and COCl. This is the one. So we are looking for, Ariz, you have to tell me, we are looking for the reagent for this. Can you tell me the reagent for this? What is the reagent for this? Sorry? Cl2. Lalma, can you tell us? You just have to look at the reagent of carboxylic acid reacting with this and turning into COCl. Can you look at the preparation of carboxylic acid in your notes, please? Preparation of carboxylic acid. We did some reactions. Anybody can Zoom? Can you please tell us? Preparation of carboxylic acid. We used a reagent. PCl3, PCl5, or SOCl2, thionyl chloride, any one. Right? So that takes away the OH on the both side and takes the Cl along. Okay? For the reaction of ethanediol chloride below, suggest the structure of compound J and K and draw them in the boxes. Now that's clear, bacho. Please pay attention. Now this is acyl chloride, diacyl chloride, and you see it's reacting with CH3COCl. Again, Lalma, can you look at the reactions of acyl chloride in which they react with alcohol? And when they react with alcohol, what happens? Their H is lost and their Cl is lost. And CH3 comes and takes the place, CH3O comes and takes the place of Cl. Okay? Sorry, ester ban jata hai. But if you look at the molecular formula of J, it's not about 1, 2, and then 3. It means both acyl chlorides react. So that's why total molecular formula, look at the molecular formula, 4 carbon indicate that this CO, look at this CO, and then this O takes the place of Cl, OCH3 on this side, and this CO CH3 on this side. That makes you the justified formula for the molecule. So हमें कैसे ललमा पता चलेगा कि दोनों एसाइड ने रिएक्ट करना है? By looking at this molecular formula. This is what I'm trying to say. Okay, but otherwise we know when the acyl chlorides react with alcohol, their H is lost and their O is lost. Okay. Okay, next is what about this? When acyl chloride arees react with amine, what do you think? When acyl chlorides react with amine, again they lose their H and this lose their Cl. So it's going to be, look at this. This H is lost, this Cl is lost, CO, NH, right, and substituted amide is formed. But look at this, what the molecular formula says. C4, what does it mean? No, only one molecule reacted. But oxygen, if you look at that, yes, तो फिर आप कहते हैं कि एक दोनों के साथ कर रहा होगा ना, like this. So one NH can react with both probably, like this. Okay, so one H this and one H with this. Got it? दोनों NH, दोनों Cl से react कर रहे हैं. Got it? Sorry, I just did. Look, मैंने इस H और इस Cl को combine कर दिया, इस H और इस Cl को combine कर दिया. Right? That made me make this molecular formula. Otherwise, I was not able to determine the molecular formula. Okay? Now, when the diethanoyl reacted with silver, this, in ethoxyethane, an oxide of carbon, L, is formed. The molecule of L has no overall dipole and has the molecular formula C4H6O. Right? C4H6O. All right? Okay, the carbon-13 spectrum for the solution of L in ethoxyethane. This one is shown in below. Use the data in the table. C4O6. Sorry, not H6O. C4O6. Okay, use the data booklet. So use the data booklet to state the boxes below the values of for the peaks in the spectrum which are due to carbon atoms in ethoxyethane. Explain what the rest of carbon-13 spectrum indicate about the structure of L. Okay, now can you identify the values here? सबकी अलग-अलग peaks होंगी ना? What about this 0 to 50? So precisely which one is this? This one? 15 वाली है ना? 15 ना? 10, 20, 30, 40 and 50, yeah. And what about this? CH2 next to O? 50 to 70, so this is 65 wali. Similarly, this is 65 and this is 15. Explain what rest of carbon-13 NMR spectrums about the structure of L, that all 4 carbon are present in one environment. There are 4 carbon and 6 oxygen, and all of them are present in one chemical environment, because after having the peaks of this ethoxyethane, there is only one peak left, and that is also carboxy. वो जो 160 to 185 होती है वो carboxy होती है ना. So all 4 carbons in the one chemical environment. Okay. Explain what rest of carbon-13 indicates about the structure of L. All carbon, yes, in same chemical environment or contribute to one peak. Okay. When pure L is reacted with the presence of CH3OH, a mixture of three compound is formed, M, N, and O. M is formed as one of the products when neither N or O is heated with aqueous acid. The table gives information of the peaks recorded in carbon-13 NMR spectrum of M, N, and O. Okay, so here are the peaks. Okay, अब देखिए जरा, for example, now M, starting with M. M has only how many peaks? One peak, and that is also in the range of carboxyl, right? So if there are two carbons, now I can predict about this. It should be this one, dioic acid. How do I got to know? Because in dioic acid, both these carbons are in the same chemical environment, and there is formula is C2. What is this? C2H2O4. C2H2O4. Is it so? C2H2O4. So what is this? 162. So M is this. I got it. Next. What about N? 53, 160, and 162. What about this, bacho? 53 N. There are three carbons. 162 clearly indicates to me that it is one carboxylic acid. And there are three carbons. And there is another at 160. That also helps me to see what? It should be what? It should be carbonyl CO. Okay? Sorry? Carboxyl, sorry. Carboxyl mean ester. It should be an ester. Next to O is CH3. क्योंकि 25 to 50 आ रही है ना? 50 to 70 आ रही है ना? So 50 to 70 for this. And 160 to 185 this, or 180 and 160 to 180 for this. Got it now? What about the last one? O. O has 4 carbons and only 2 peaks. 4 carbons and only 2 peaks. A carboxyl hai. So all 4 carbon are actually carboxyl. All 4 are carboxyl, na? Because this C4H6O4. So this is carboxyl. Okay. But there is only 4 hydrogens in this. Am I right? So must be something like this. Is it so? Both CH3s must be in the 50 to 70 range. That's why I put them next to oxygen. And then both these carboxyl, 162, 185. The last one, L. Okay, I've already drawn the L here. Look, the L says C4H6. So this is how I have already drawn this. It's a cyclic ester, right? So all 4 in one chemical environment, right? There's a 1 peak for this. This is the only possible option with 1 peak. Okay, so this is how we look at this. We'll continue this. This was actually a mixing of organic with carbon-13. Thank you very much.